Hello and welcome everybody. Greetings to our worldwide partners, customers, and all others who are interested in this webinar, Power Analyzer for Industry 4.0. At the beginning, just some short organizational stuff to allow other persons and people to log in into our webinar. Please feel free to ask questions with the chat window to your right side. Okay, the questions are anonymous. Nobody else can see those questions, just me and my colleague. And we are going to answer all of those questions at the end of the webinar. Also, you can download the necessary handouts to this webinar, which are also on your right side of your screen. I think it's below the chat window. At the end of the webinar, we would kindly like to ask you to give us some answers to a survey. It's, I think, just 4 questions, which we would like to have as a feedback to make our webinar sessions better in the future, because we are going to have further webinars in the future. They are already mentioned on our homepage. So that's so far regarding organizational stuff. A short agenda. I'm going to talk, I think, about 30 seconds about Devetron for those who don't know Devetron, who we are and what we do. And then we are going to jump directly to the topic, Power Analyzer for Industry 4.0. We are going to talk about typical interfaces. My colleague is going to show you a live demonstration. And at the end, we are going to talk about 3 or 4 examples that we have already realized. And yeah, that's so far. Just a short notice about your speakers today. The know-how expert today is Verena Niederkofler. Verena, do you want to say something?
Just also hello and welcome to the webinar, and I'm gonna do the second part later.
Perfect. And I myself, I'm Ivica Baresic. I'm the business developer and sales for Austria. And just to let you know, we are going to mute and turn off the camera of the person who is not speaking or who is not involved in the session, so you can focus, and the quality of the stream should also become better then. So let's jump in the 30 seconds about Devetron. Devetron is a worldwide acting company with 120 employees. Headquarters is in Austria, in Graz, and we have 3 subsidiaries in Germany, USA, and China. We are active in actually more than 25 countries, and we have sold an active 25,000 systems and 400,000 channels, which is making Devetron a know-how expert in measurement systems and applications. Portfolio, of course, in the middle we see the Power Analyzer. It's a part of this webinar, so yes, of course, Power Analyzers we have in our portfolio, and we have other solutions, measurement solutions, for example, on the left side, mobile measurement solutions. Of course, we offer all kinds of service and support for our systems, and also calibration if needed, accredited for all our systems and products. So let's jump into the topic. The question is, what does a Power Analyzer has to do with Industry 4.0? During our live demonstration later on by my colleague, we are going to see how easy, intuitive, and simple a handling of a Power Analyzer in these days has to be. Also, the system needs to stay flexible, hardware and software side. So these are the first 2 core parts. But the most important thing is that the Power Analyzer has to be connected and has to have the ability to be connected to a master computer or a testbed in a bigger network. To be able so, you have to have multiple amounts of interfaces as well. Also, what is very important, not just to be able to send information over that network, but also the part to be remote controlled. So the possibility to be remote controlled is a huge part in the Industry 4.0. Our Power Analyzers offer, of course, all of those mentioned points. I'm not going to talk about all the features that our power analyzer offer, but what you need to know is, and what's the most important thing in this case of Industry 4.0 is that our system can handle in one single unit multiple phases and multiple other kinds of signals. This is very important to know because synchronization is always a huge part in Industry 4.0. So what is also important to know is that we have the needed safety category to install our power analyzers in needed surroundings. Our oxygen measurement software, so-called Oxygen, analyzes and calculate needed parameters, data and signals directly during online measurement. And this allows us to only communicate those necessary calculated signals over the network to the master computer or embed or any other systems, so they can handle only those needed values. You don't put your network under rough circumstances because you send all unnecessary data over those networks. About the handling and the calculation and the software, we are going to see, of course, in a live demonstration. To be able to communicate with a network, a power analyzer needs to have different kind of interfaces. Remote control is one part of it. Remote control, as we can see here, because our systems are based on Windows, we can use, as simple as it is, Windows remote control. But it's such a huge benefit if you can sit up in your office, connect via Windows remote control to your power analyzer, and see if still everything is working the way you want to have it to work. Also, VNC is a typical program to do so. What we have built in our software is the so-called SCP, SCPI also said. This SCP protocol interface allows other programs to control our power analyzer and the software. You will see it in the online demonstration later on. So what is also important is, as I already said before, is that the system can be is customizable, not only by hardware. We have our hardware modules that are that can be customized by the customer himself or by the user himself at every given time, but it's also necessary to stay customizable with the software. And therefore, we offer a so-called plugin interface where you can program with C++ a part of a plugin or a plugin itself that fits perfectly for your application. Also, it is important to know that it is necessary to do online data manipulation and calculations, and that the big mathematic library with functions is necessary therefore. All the needed informations regarding plugin interface and C++ programming plugins is available, of course, on GitHub. So other common interfaces, so sending data over interfaces is, of course, the second important part. And therefore, of course, CAN out XCP over Ethernet is always a part. EtherCAT should also be mentioned. What Devatron offers additionally is the Ethernet high-speed interface to be able to communicate a huge amount of data, because we can and we do data recording. So we can, for example, have a signal sampled with 2 or 10 megahertz. And this is a huge amount of data. And with the Ethernet high-speed interface, we are able to shift all the data to a necessary master computer or anything else. To complete the package of logging in or to have an embedded power analyzer in a bigger system is an external timing possibility. So our system or any power analyzer should be able to be synchronized with any testbed or anything else. And therefore, PTP, ARIC, and GPS are just some points to mention. Once again, a short reminder before going now into the live demonstration. Please use the chat window on the right side to ask questions. Again, they are anonymous. Nobody else can see them. And me and my colleague are going to answer them at the end of the webinar. Verena, if you want, the stage is yours.
Okay, thank you very much. Okay, you should be able to see my screen now. Okay, good. Okay, so I would like to start with a small presentation about the testbed interfaces to give you a short overview about the most important facts about the different interfaces, and then we will come to the live demonstration where I set up a small measurement, and then I can show you, or I will show you, how we can set up or create a setup with our measurement software Oxygen, and how we can simply integrate this into a testbed environment using SCP or SCPI. Okay, so for the overview, the first testbed interface I would like to show you is SCPI or SCP. So this is a plain text interface via Ethernet. The communication layer is TCP/IP. There's a huge and broad spectrum of commands available, like start and stopping of the measurement. The setup can be loaded and saved. The name of a data file can be set beforehand, and also different channel settings can be accessed. The transfer of single values continuously is also possible, and buffered data can also be accessed or transferred. Up to or more than 100 channels can be transferred with 100 samples per second for the continuous transfer of single values, and up to 10 kilosamples per second with the ELOG mechanism. That's the buffered data, which you will see afterwards. With SCPI, one connection to the measurement device is possible. In contrary, there, the data stream is also available. This is the high-speed interface my colleague mentioned before. So this is a binary interface via Ethernet. Also, the communication layer is TCP/IP and is configured with SCP. So the same comments are available. This is a high-speed interface for the transfer to transfer raw data. So up to 2 megasamples per second are possible, and also more than 100 channels can be transferred. One of the differences to SCPI is that more connections to the measurement device are available, so you can install more clients and transfer data. The next interface I would like to show you is XCP. So that's a binary interface via Ethernet. The communication layer can be chosen from TCP/IP or UDP, and the data transfer works with Canopy or Incas. Other than a data transfer, also some comments are available, so start and stop of the measurement can be done with XCP too. Up to 10 kilosamples per second is available there, and up to 20 channels can be transferred. The next interface is EtherCAT. That's one of the more complicated interfaces, since and another DORN EtherCAT module is necessary. So an own module is necessary to be able to use EtherCAT, so the measurement device can act as an EtherCAT slave and send data to an EtherCAT master. With EtherCAT, you can start and stop the measurement, and additionally, a setup can be loaded. Up to 500 samples per second can be transferred, and up to 100 channels or parameters are available there. CAN is a very common and known interface, so I don't want to go into much detail here. Communication layer is CAN, and CAN signals can be decoded and visualized. which are described in a DBC file. Canout is also supported by us, so the cyclic transfer of data up to 100 Hertz. And the last thing I want to mention here is the Ethernet receiver and sender. So I put this on one slide, but those two, the Ethernet sender and receiver, can be used individually, so they're not dependent of each other. The Ethernet sender, the data can be sent cyclically via UDP, whereby the XML file will be generated automatically by Oxygen whenever it's set up. And this XML file can then be used or has to be used on another client to receive the data. So to receive the data, also the Ethernet receiver can be used, but doesn't have to be used. And the data is received, which is described in this XML file. Up to or more than 100 channels can be sent and received. And for the Ethernet sender, we have a data transfer up to 100 samples per second, and for the receiver up to 1 kilosample per second. The communication layer here is UDP. Okay, so now we come to the live demonstrations. I will just start Oxygen. So here you should see now my measurement screen of our measurement software Oxygen. So this is just the empty measurement screen. And first, I would like to show you how we can easily set up or create a setup for a power measurement. And then I will show you how we can integrate all this easily into a testbed environment with SCPI, Skippy. Okay, first, I have a one-phase measurement here, so we measure current and voltage. And in order to do a power measurement, we will open the channel settings first, the channel list. Here you can see those two channels which are active. So this is our voltage channel, which we rename real quickly. And here we have our current channel. Okay, for the voltage channel, I don't need any more settings. And for the current setting, for the current channel, I use a current clamp. So I have to set a scaling or sensitivity here. So I just click on the scaling here, select my sensitivity, and enter the sensitivity here. So this current clamp uses 100 millivolts per ampere. Okay. So we can see the scaling has been set, and this was actually it. So the settings of the channels are done. And to do a power measurement now, we simply click on the voltage channel, we select the current channel, and click on this button down here. And a power group will automatically be created. So as you can see, the current, the voltage, and also the power right here. So this is just the same as for a three-phase measurement, for example. Then we simply select the voltage and the current channel for each phase, and also click on the same button, and automatically a power group will be created with the right wiring type. For example, if we have a three-phase measurement here, the wiring type can, of course, be changed afterwards, depending on if we use the neutral line here, 3-wire or 4-wire. Okay, so as we have a one-phase measurement, we select this wiring type. And in the settings, I also want to calculate the harmonics. So this is it with the settings. I don't want to go into much detail here since this is not the focus. But I just want to rename my power group up here in case we would have more power groups. So of course, more power groups can be created. It's not limited to one power group. And like this, we have an overview of the different power groups. So we close the settings up here. And as you can see in a channel list, there's a new section, which is called Power Groups. And here is my power group I just created. So just to give you a real quick overview on the parameters, which are calculated automatically, so there's no more effort needed to enter any values or calculations to get all these parameters. Right here we have the fundamental frequency, which is automatically calculated. For voltage, for example, we have the harmonic parameters, the total RMS and the fundamental RMS value is calculated for each phase, and the total, which is of course the same right now since we just have one phase. The same is calculated for the current, and then we also have different parameters for powers, power factor, and energy. I don't want to go into much detail right here since there's a lot of parameters which can be which are calculated. And to show you this in a little bit more graphical way, we come back to our measurement screen. So we just close the data channels menu here, open it in a small way, and just drag and drop this power group onto the screen. And then we can resize it and readjust it on the screen. As you can see, I'm doing this on my desktop here, but it's really intuitive. It's really easy with the drag and drop mechanism. Also with the resizing of the instruments, it's really how we are used to, or how we know it from smartphones, from tablets with the multi-touch display. So the screen can individually be created for each measurement. It's really easy to do on the multi-touch display on the power analyzer. So I dragged this out 3 times to show you the different symbols up here. Of course, this can be done in any way. We have a lot of instruments available here in order to set it up the way you would like to. So for the power instrument here, for the first symbol we have, or we get a table with the most important parameters to get an overview. If we click on the second symbol, we get the phase diagram of each phase, just the one phase right here. And for the third symbol, we get a display for the harmonics for voltage and current. Okay, so this was it. This was the creation of the setup. So it's really easy, it's really fast. And now I would like to show you how we can integrate this into a testbed environment. So the first step is to open the system settings here. So just drag this open. We go to remote control and enable remote control. And here we would like to use SCP over Ethernet. So we just enable it, and now we can already see the port number used here, which can be, of course, changed if necessary. So we just close this. And now to show you how we can integrate this really easily, I'm using the SCP, our Oxygen SCP app. So I will just minimize Oxygen in the background. And here you can see our Oxygen SCP app. This app is freely available for download on our website. It's independent. It doesn't have anything to do with Oxygen by itself. So it's an own program which can be used. It's based on LabVIEW. So also the SCP library for LabVIEW is available for download. So this is just an example how the interface for SCP could look like. But of course, everyone can program their own interface with their own buttons they would like to use. So just to give you a quick overview, we have 3 tabs here. I will explain. So the general tab with the comments for identification number, version number. Reset would reset the settings in Oxygen, and to ask about the arrows. We have some setup management buttons here to load a setup, set the file name, and to query channel list, and the recording control. And of course, the user comment, since there's a broad spectrum of comments available. So here every other comment can be entered here. Then we have the measurement values tab and the external data logging tab for the buffered data, which I will come to a little bit later on. Okay. So in order so you can see what's happening in behind, I will just open Oxygen again and put the app in front of Oxygen. But as I said before, it's independent from Oxygen. Okay, so the first step is we want to connect with our software. So as you can see up here, we need the IP address or the host name and the port number. The port number is the port number we have seen before in the system settings. Okay, so I wrote down my IP address and the port number is 10001, as we have seen before in Oxygen, and we just click connect. We can see the indicator turned green, so we are connected. We are already connected with Oxygen. We could start recording right now. It's a little bit small, but down here it also says remote connection active. I don't know if you can see it. I hope so, but otherwise this is a little notification which tells you that a remote connection is active. Oxygen is also freely available to download on our software. So if you would like, you can also download the SCP app and Oxygen and try everything by yourself later on if you would like to. You can also find the manual with the SCP comments, so you can have a look and see and try it out by yourself. Okay, so for example, we could ask for the version number here. You can see the version number of the app and Oxygen version number. We could reset the settings in Oxygen here. Okay, so before we want to start a measurement, we would probably like to load a different setup, maybe because we have different measurements. So we just simply click on this button and select a setup. So this setup has, of course, be available on the measurement device, and then we execute the comment here. As you can see in the background, a new setup is loaded. Okay, so before we want to start recording, we also want to set a file name, because maybe with the same setup, we also have we want to do more than one test run. So we also click on this button, and we already have a test run 1, so we name this test run 2. Save it and execute the comment with this button. Okay, so the next measurement or the next recording will be saved in this path with this name. Here we can query the channel list, so the whole list we have seen in Oxygen. So if we execute this here, we get the whole list of channels. So these are all the power parameters which are calculated in the power group. Okay, so if we are not really sitting somewhere where we can see the screen and we want to know before if data is already coming into our measurement device, we have a comment where we can ask about it, which is called acquisition state, and we execute it, and we can see here started. So just to show you, I will stop the acquisition right now, and as you can see, no data is coming into the measurement device. And if we ask of the acquisition state, we see here stopped. So something might be wrong, and we can go look where the problem is. So I just start acquisition again. Data, as you can see in the background, is coming into the measurement device again. Good. Right now, as you can see, if I close this app, I can actually change something here on my screen. So I could on the measurement device directly, I could also start the recording and do something else or change the settings. If I want to only be able to change something with this app, so I don't want anyone else maybe during a recording or also after the recording, so I don't want anyone else to change the settings, I can lock the screen with the app too, or from here with skipping system on. I can execute the command here. And now you can see here, screen lock, there was a small notification. I don't know if you have seen it. But anyways, if I want to start the recording, I get the notification your screen is locked. So I cannot open the channel settings. I cannot change anything here right now. Of course, I can also unlock it again. Then I get the notification here, screen is unlocked. And now I can again open the channel settings, change the settings, start a recording, and do something on my measurement screen and measurement device directly. Okay, so now I want to start the first recording with the start recording button here. Also, of course, could be used, the user comment can be used for this comment. And as we can see, Oxygen has started the recording, as we can see for the with the red border and down here. And also the recording indicator in the lower left corner says recording. Okay, if we, of course, we can see here the recording indicator has turned red, but of course there's also comment, store state to ask about the state of the storing or of the recording if we cannot see the measurement screen or the measurement device directly. As we can see here, it started. If we pause the recording, this turns orange. If we ask about the state, it says paused. And we can start the recording again. See the recording is going on in the background. And then we can, of course, stop the recording. And we can ask about the state of the recording again. It says stopped. A nice thing to know is maybe if we really have a long recording or a lot of data which will be saved in a measurement file afterwards, or if we load a setup and it takes some seconds, we can ask about the state here and it would say stopping if the device is still saving or loading the setup. So we know we still have to wait some seconds maybe to start the next recording or to execute the next comment. Okay, so if we come here to the next tab, it says measurement values. We can see here, we can actually display some values, some channels. Of course, if we maybe would like to see, does the data make sense? Can I start my recording or also during the recording to see, does the data look good? Can I, or do I have to stop recording to see if something is wrong? So we have 6 channels available here. So in this app, of course, and we can set an aggregation rate from 1 milliseconds to 5 seconds, but it also depends a little bit on the sampling rate. So it might be a little bit shorter if we have a high sampling rate. So the aggregation rate is the rate, the time where the data gets collected and gets transferred here, since this is not a transfer of raw data, of course. So we just simply drag and drop a desired channel up here, or we can also enter the channel name, of course. We can set the aggregation rate maybe to 100 milliseconds. As you can see down here, it's set to 100 milliseconds. And then we can just simply start the transfer, and we can see data is coming into our app. So this is the same as we can see here in the background in Oxygen too. In Oxygen, of course, is the raw data, and here we just get transferred some data. To stop the transfer, we just simply click stop. and the transfer will be stopped. Okay, in order to be able to see buffer data, we go to the external data logging or the eLog tab. And we can again see 6 channels can be displayed here. We can choose between calculations, so we can see the average, minimum, maximum, or the RMS value with this period of time. We can set here, and we can choose a timestamp. Here we can see buffered data, or we can access buffered data up to 20 seconds into the past. So in order to do so, we can again drag and drop desired channels up here. So we also use the voltage fundamental RMS value and calculate the average over 100 milliseconds. Okay. And then we'll just simply click on Start Buffer. As you can see, all these settings are set here and are executed, but we cannot see any data right now since the values are only saved into the buffer now. So to be able to see some data, we have to fetch the data. So this is not a continuous transfer of data. We always have to fetch data from the buffer. So here we can see all this data has been in the buffer. So this is the average calculation of over 100 milliseconds right now. So we can again fetch data and we get all the data in the buffer. To simply stop the buffer, we click this button, and now the buffer is stopped. We can change the settings here or do something else. As you can see, you don't have to be recording to be able to use this. Okay, so if you have any questions, just use the chat tool or the question tool. If you would like to have a detailed explanation or some information about any other interface, just feel free to email me and I can give you more information about other interfaces, about this interface. So just use the chat tool or the email address. Okay, so this was a small presentation, and to show you how simple it can be to create a setup and to integrate the measurement device into a testbed environment. And I would again give you control and the word.
Okay, perfect. Thank you, Verena. So
thank you.
I'm going to take over. Verena, just tell me if it is the right screen. Just to be sure that everybody sees what I would like them to see.
Yes.
Okay, so let's go. So before going into the already mentioned examples at the very end of the webinar, I have already seen that we have 3 questions. Thank you for those. They are going to be answered, and as you can see, nobody else see those questions, that just the person who asked it. So feel free to ask us questions. We are here for you. And yeah, that's just a short hint. As Verena already said, ask us questions. We are here for them. About the examples, I have, I think, 3 or 4 examples here. Example 1 would be Davidson power analyzer connected to a crystalline siped test bed. Skippy is the thing or the protocol interface which is used very often to control our system, and in the major part of the cases, another interface is used to send the data to the overhead or the master computer. And in this case, it was XCP. It was sent to the crystalline siped testbed and to a third-party instrument. This is in this example what we also did is another part where again Skippy was used to that was an automobile customer in Germany. Skippy was used to control our system again, and we did send per EtherCAT the data back to Crystalline Site. We saved the data as an MDA4 data file as well for Crystalline Site, and we used external signal generator for synchronizing our system, and that was a PTP master in this case. So as I said, those three parts: remote control, sending information over another interface, and synchronization, everything part in this example. A very simple solution, but works perfectly fine, is of course information sent from us and received from other systems on our system, on our measurement system via CAN. So we send information via CAN out, and we receive information via CAN to save it in our system to synchronize it with other measurement data. Example 4, nothing with test beds, but it was measuring at wind solution, wind energy park. Again, of course, SCP used to control our system completely. The technician there was also sitting in his home office and also connected via remote control to see live on the Windows machine, on our power analyzer if everything is working. And we did send data via Modbus, or we are going to send. So this is just a project that is going to be realized. Sorry, we are going to send data with the Modbus to the wind park back. So these are just some short examples of possibilities where the Industry 4.0 is taking part of the power analyzer. So again, I see 3 questions. I'm going to answer. We are going to answer them. Sorry, Verena. Of course, there are some. I see there are questions also pointed towards you. Again, just if you have questions, ask them. First question: is the shown SCP app free, available for download, or can it be bought? Verena, I think
no, it's freely available as a download on our website. So just go on our website. You will be directed to the download page, so you can download not only Oxygen for free, but also the SCP app. So, and also, as I said before, also the SCP library for lab use available if anyone would like to program their own interface or use that library. So you can download the SCP app and the library and to try everything out by yourself if you would like.
So to perfectly clarify, you don't need hardware to test this. You can simulate hardware on any given computer with Oxygen?
Yes, so with Oxygen, also the DEVATRON Explorer will be installed, and there you can simulate hardware. You get simulated signals, and you can use Oxygen then to see those signals, and of course you can use the SCP app to test or to try this out. So you don't need hardware for it now.
Perfect. So if you have any further questions towards this tool or Oxygen and installation, Verena and myself, we are of course always ready to answer any questions. If you don't answer those questions or don't ask those questions now, please contact us also via email or phone. For example, my contact data are always available on LinkedIn. So if you contact me, it's no problem. I'm gonna refer directly to Verena and the other know-how experts in the house to get the proper answer to you. The next question would be, again, to you, Verena, as I can see. Is it possible to change the sampling rate via SCP?
Yes. So you can, of course, access some order channel settings, and you can also change the sampling rate with SCP with the next release, so which will be very soon, where you can also change the sampling rate, so you don't need to be on the measurement device for that.
Perfect, perfect. So that's, I think, perfectly answered. I think so, yeah. And the next question would be, we would need to synchronize a power analyzer with other measurement systems, for example, temperature and vibration. strain gauge is here as well mentioned. Is it possible with the Devitron power analyzer? Varen, if this is okay, I will take over.
Sure.
The answer to that question is yes and no. Yes, you can synchronize, as already shown in the presentation or in the webinar, our system with other systems. PTP, GPS, ARIC are just some examples on how to do it and how to make it. The no part is, no, you should not need to synchronize our system with other measurement solutions, because our systems are multi-measurement systems which can handle multiple amounts of signals. I'm not prepared for this, so I'm just, Verena, can you see the
Yes.
homepage now? Okay, so I'm just jumping to the homepage. I'm going to jump to the, of course, to the English part, because we are in the English session. And if you go to products and click on products and then to signal conditioning, you will see that we are jumping directly to the signal conditioning, and there you see our TRION modules. Those TRION modules are the modular part of our system. And here in the blue part, I'm going to make it a little bit bigger so you can see it better. You see all amount or different kind of signals that can be used within one single unit, also within the power analyzer, which means all those signals are synchronized by our internal synchronization bus, and you don't have to worry about synchronization. The benefit is you can use those signals and calculate any given parameters if needed, if you have to combine the signals. So yes, you can synchronize, but the necessity to do it with other measurement systems, there is no necessity anymore for this. So, I have not seen any further questions. So at the end, about 2 weeks ago, we published a white paper regarding this topic. So it's freely available, I think, on the homepage. Verena, correct me if I'm wrong.
Yes, on the website, there's, I'm not sure which section, but you can find all the white papers, and this white paper is about the tested interfaces.
Okay, perfect. And the only thing left to say is please follow us on social media. We are available, everybody is available on social media, me, myself as well. And we are going to inform you over those social medias as well about further webinars. They're going to be, they're already announced on our homepage as well. And under Academy, you can see them. And if you still have unanswered question, again, please contact us. We are here for you. Me and my colleagues, via email or phone or whatever you want, just ask us. We are there for you. And at the end, please take some time to answer those 3 or 4 questions after this webinar, and to help us to improve our webinar, and of course register to our newsletter. Thank you and bye-bye.
Thank you. Bye.